Assalamualaikum. We now discuss chapter 5. The topic is ordinary differential equations. And this topic is going to be a tough one, tougher than all the other chapters that we discussed before this. But it is very important because in the exam you will find one solid question out of 5 on this topic. So it is very important for you to pay attention. Okay, so this is part 1. So we discuss the nature of a problem. Two problems that we are going to discuss is initial value problem, we denote as IVP, and the other one is boundary value problem. We call it BVP for short. So the first problem will involve three methods: Taylor series method, Range kata of order 2 method, and Range kata of order 4 method. Well, the other one is a method called finite difference method. So altogether, we will discuss 4 different methods for solving the problem. So y prime, so as a background, is a symbol for dy dx. And y double prime is a symbol for second order, which is d2y dx squared. So something that you should know. You should have the notes with you ready. This one here, ODE, so chapter 5. So in these notes, we discuss the background of problem, some example of problems that we already have. And we also discuss, pay particular attention to fast examples, beginning with 1, Taylor series method, and then you go to fast example 5. So 5 examples are given here for you to study. Okay, so we discussed the types of problem that we are going to have. First is first order ODE, can be written in this form: ax, which is a function of x, y prime, plus bx, another function of x, y equals cx, another function of x. So notice that ax means a function of x, no y. Same thing with b and c. So any equation written in this form, we call it linear ODE, linear ODE. So it has this form. So what we are interested here is to make y prime as a subject. For example, we have this problem: 3x squared y prime plus 4x minus 1 y equal to x plus 1. So we make y prime as a subject. This is what we get. Putting 3x squared and 4x minus 1 y to the right hand side. So we have y prime as a subject here. So everything on the right hand side, which is this one here, is a function called fxy. Then we can formulate the problem of initial value problem. Given y prime as a function of x and y, which is this one here, and also given the initial values. Initial values are the first value, which is x0 and y0. x0 is given, y0 is given. So we need to find y1, y2, and so on. So here is the map. So we have y0, x0, so the values on the left hand side, which is this one here, are given. And we know x1, the difference between x0 and x1 is h, which is the width of the interval. It can be found actually, no need just simple calculation, just x1 minus x0. H is just x1 minus x0. So h is the width of the interval given, which is given. So from here we need to find y1, y2, and everything else. So in the exam, normally we need to find y1, or sometimes y1 and y2. So this is called initial value problem. So we are going to discuss 3 methods as mentioned earlier: Taylor series method, Range kata of order 2 method, and Range kata of order 4 method. So we will do that. The second part of the problem is on second order ODE. So second order ODE or second order ordinary differential equation can be written in general form like this: ax y double prime plus bx y prime plus cxy equal d of x. A, B, C, and D are function of x only, no y. Example, this one here, 2x minus 1 y double prime plus 3x squared y prime minus 5xy equal x squared plus 1. So this is one good example. So this kind of equation is called linear ODE. Linear ODE. We only discuss linear ODE of order 2 for this problem. So the whole thing becomes what we call boundary value problem. Why do we call boundary? Because it involves boundaries, left and right. You see left, x0 and y0 are given. Xn and yn on the right are given. We need to find the values of y in between. For example, y1, y2, and so on until yn minus 1. So this is a problem. Given the boundaries, this one here is left, this one here is right. So find y1, y2 until yn minus 1. So this difference between x0 and x1, we call it h, which is the width of the interval. They must be uniform. H must be constant in this case. So two types of problems that we are going to discuss. So that will end part 1 of this discussion. Thank you. You need to refer to part 2 and so on after this. Thank you.